Hello everyone, today I will be talking about this osmotic fragility test, and then I will also demonstrate the Sanford method. So let's get started. So firstly, what is osmosis? Osmosis is the movement of water across a semi-permeable membrane from an area of low solute concentration to high solute concentration. So see, here this side is the low solute concentration, and then this side is the high solute concentration. And between them, this is the semi-permeable membrane. So after some time, this water will move to this low concentrated solution to the high concentrated solution, so that their concentration will be equal. So this is the osmosis. So what is osmotic fragility test? Osmotic fragility test, we use this test to measure the erythrocyte resistant to hemolysis. So what we are doing in this test? In this test, we use the saline solution, and saline solution is the sodium chloride solution. To be clear, let me explain you with this picture. Here we have isotonic solution, hypotonic solution, and hypotonic solution. Isotonic solution is the 0.9% sodium chloride solution. Hypotonic is more than 0.9% and hypotonic is less than 0.9%. Here, what happened to the red blood cell? If the red blood cells are inside the isotonic solution, their size will be the same, because isotonic solution is the solution which is the same concentration as the cells. And then this hypotonic solution, they have the more than 0.9%. So if the solution has the high concentration, and inside the red blood cell it is low concentration. So according to the osmosis, the water will be released from the cells. So this red blood cell will be shrink. So what about the hypotonic solution? If the red blood cell is inside the hypotonic solution, this solution has the low concentration, right? And then inside the cell it is high concentration. So according to the osmosis, the water will go inside the cells. So the cells will be bigger, and then it can even pass out. So the red blood cell will be hemolyzed in the hypotonic solution. So we are using the hypotonic solution, serial hypotonic solution, to see the erythrocyte resistant to the hemolysis. So let's see. Here, this is the isotonic solution. In the isotonic solution, the red blood cell, the size will be the same. This is hypotonic solution. In the hypotonic solution, the red blood cell will be bigger, and then it can even hemolyze. So let's see this picture. This is the normal blood. In the normal red blood cells, we have the serial concentration of sodium chloride concentration 0.7%, 0.65%, 0.6, 0.55, 0.5%, and these serial concentrations are there. And then here it is the normal red blood cell. So the normal red blood cell is resistant to the 0.7%. So they are not hemolyzed here. They are not hemolyzed in the 0.75% also. They are not also hemolyzed in the 0.6%. Here they started hemolyzing from the 0.45%. But in hereditary spherocytosis, means these spherocytes are like that. They are the spherical shapes of the red blood cell. Red blood cells are normally, they are biconcave discs, but in spherocyte they are already round shaped. So and then they are not resistant to the hemolysis. So their fragility is high. So in the hereditary spherocytosis, they started hemolyzing from the 0.65%. So their fragility is low. So this is the theory part of the osmotic fragility test. So I will be demonstrating about this osmotic fragility test by using the Sanford method. I use this method because this method is just using the visual method. And we have another method called DAISY method. In DAISY method, we will use the spectrophotometer to see the color changes. But here, we will use the naked eye to see the pink tinge of the cells. Here, you can see pink tinge of the color. It is the indicating the hemolysis. So first of all, we need to collect the materials, and then I already prepared the 1% sodium chloride solution. These are the required materials, sodium chloride, and I have already prepared the 1% sodium chloride and distilled water. And I have labeled the 12 tubes, 1, 2, 3, 4, 5, 6 to 12. And then we need the defibrinated blood. After collecting the required materials, first I need to prepare those tubes according to their concentration. I have 12 tubes, 1 to 12. And then I will be preparing them by mixing with the sodium chloride and distilled water. Here, to prepare the 0.9% concentration, I will be mixing the 1% sodium chloride, 4.5 ml and 0.5 ml of distilled water. Like that only, we will prepare all the tubes by mixing the 1% sodium chloride and distilled water. This is the 1% sodium chloride and distilled water. I will be mixing them according to the table. After preparing the cereal dilutions, I will add the 1 drop of defibrinated blood to all the tubes. Then I will incubate all those tubes at the 37 degrees Celsius for 1 hour, at least 1 hour. And then we will observe the result after 1 hour. This is the result after 1 hour. This is 0.9% to the cereal hypotonic solution till 0.00%. Here you can see till the 0.55% is only clear supernatant without hemolysis. And then starting from the tube number 6, 0.5% hemolysis is started. You can see the pink color hemolysis, the supernatant is there. And then the hemolysis starting from the tube number 6 till the tube 0.0%. And then here the hemolysis is completed from the tube 11 and 12. You can see the homogeneous pink color there. So we can say this is the complete hemolysis. So as the final result, we started seeing the hemolysis from the 0.5%. And the hemolysis is completed at 0.1% and 0.00%. So now I am going to talk about the clinical significance of this OFT. The normal values of OFT is starting from the 0.5% sodium chloride and completed at the 0.3% sodium chloride. So my test, I can say this RBC's or osmotic fragility test is normal. So what are the abnormal tests? So these can be the increased osmotic fragility test, and then decreased osmotic fragility tests are there. In increased osmotic fragility tests, so what are the causes? Hereditary spherocytosis. This is the common cause of the increased osmotic fragility test. For decreased osmotic fragility test, these are the causes: sickle cell anemia and iron deficiency anemia, thalassemia, polycythemia. This is the end of my experiment explanation. Thank you for watching my video. Bye bye.